Hello class. In this video we will be looking at 10.2 systems of linear equations, not in two variables but several variables. And even though we can do 4 variables, 5 variables, 10 variables, 20 variables, we're only going to look at 3. Okay. All right. So 10.2. Systems of linear equations in several variables. Okay, so the things that are similar here in this section compared with 10.1 is sort of like the elimination method. Okay, that's going to be similar. And also, if you remember, when we have infinitely many solutions, we say, oh, okay, let x equals t, and then y equals negative t plus 1. That deal? Okay, that's still going to be a part of this. Okay. All right, so the method that we are going to be looking at is triangular form. Triangular form and back substitution. Okay, and this here is actually called Gaussian elimination. Okay, and again, we, as far as solutions go, we might have one solution, we might have none, we might have infinitely many. Okay. So what we're going to be doing is we're going to be looking at system of 3 equations. So that looks like this. So we'll start off looking like this. Let me show you. Maybe you have something like this, x minus 2y minus z equals 1, negative x plus 3y plus 3z equals 4, and 2x minus 3y plus z equals 10. So you might start off with something like this, and what happens is your goal is to try to get it to look like triangular form. So let me show you what that looks like. So we do this and try to get it, your system, in triangular form. And triangular form will look like this. So you start off with this full system here, and then what happens is you use elimination method several times until you get it to look like this, where you have an equation with all 3 variables. So maybe it looks something like this. Okay, so you have one with all 3, and then you have one with just y and z. So maybe it has this, y plus 2z equals 5. And you have one with just z. Okay, so we call this triangular form because what happens is you have this sort of triangle here of zeros or nothing. Okay, and what happens is if you can get it in this triangular form, then you can use back substitution. Okay, to solve. And what ends up happening here is you have to solve for all three variables, not just x, not just y, but you have to solve for x, y, and z. Okay. All right. So then back substitution. Okay. So you you look at that triangular form, right? And we see that z equals 3, right? Here, let me write it. I'm going to kind of write it backwards. So we have z equals 3, right? And so if z equals 3, then I can plug it into that second one because I have only these two variables, y and z, right? So if I plug in for the z, then I can solve for y, right? So let's do that. So I'm going to substitute 3 in for z. And I get that y plus 6 equals 5. And subtract 6 on both sides. And I get y equals -1. Okay. And so I know what z is. Z is 3. Okay. That came from over here. Okay. Now I know what y is. And all I need is x. Okay. So now I can use that top equation. Okay. So remember, let's go back here. Triangular form. You know one of your answers. When it's in triangular form, you know one of the answers to one of the variables. We know the answer to z. Z is 3. So what happens is you can back substitute into this one. So if you replace the z with 3, then you can solve for y, right? So then now you have a solution for z, now you have a solution for y, and then you can back substitute over here. Okay, because now you can substitute for x, you can substitute for y, and now you can solve for z. So that's what we're going to do now. We're going to take that top equation, x minus 2y minus z equals 1. X minus 2y minus z equals 1. And I'm going to substitute for the x and the y, not the x, the y and the z, because y equals -1 and z equals 3. Okay, so x plus 2 minus 3 equals 1. X minus 1 equals 1. Add 1 to both sides. X equals 2. Okay, so here, now I have all three answers. And just like in the previous section where you wrote your answer as a point x, y, now you write your answer as a three-dimensional point x, y, and z. Okay, so that's what you're going to be doing. You're going to be using back substitution once you get your system in triangular form. Okay, so the question really is, and the work is actually in getting it to triangular form. Okay, and once you do that, then you do all of this work to solve for x, y, and z. Okay, all right, so back substitution, that'll be the last step. So let's take a look at an example so that we can see how we use elimination method to get our system into triangular form. Okay, so getting triangular form. Okay, so it might say in your homework, solve by Gaussian elimination. That means get it in triangular form and then use back substitution. Okay. All right. Suppose this is your system. X minus 2y plus 3z equals 1. X plus 2y minus z equals 13. 3x plus 2y minus 5z equals 3. Okay. I always like to check to see if any of the equations have a common factor so that I can make the number smaller, but none of these do. So, okay. All right. So we need to, let me highlight them. Okay. So we need to get this triangle right here. We need to get this triangle of terms eliminated. Okay. So the way we do that is very systematic. Okay. So, what you do first, here, let me get yellow. Okay. So we're going to be using that top equation. Here, I'll use colors. You use this to eliminate this one first. Okay. And that looks easy, right? Just multiply that top one by -1 and then add it, right? Okay. And then I'm going to use that first one again, and I'm going to eliminate this. So I would need to multiply that top one by -3, right? That way it cancels with that +3. Okay. And then, let me use a different color. Once you get those two eliminated, you are on your way. Okay, so you do those yellow ones first. Okay, and then we're going to eliminate this one, right? Because it's this triangle that we need to eliminate. So I'm going to eliminate that by using this. Okay. All right, but things will change because as you combine equations using like elimination method, all the other coefficients are going to change. Okay, so let's take a look. So I'm going to start off by eliminating those the yellow ones first, the one in the middle first, and then the bottom one, and then I'll eliminate that green one. Okay, so let me use yellow. All right, so if I want to eliminate that x, I need to multiply this by -1, right? Okay, so one thing you have to be careful with here is there's going to be a lot of multiplying and adding and multiplying and adding and a lot of that, a lot of simple operations, but a lot of those operations in one step. So there's going to be lots of room for error here. So, just take your time when you're doing these problems in the homework. Just, take your time, be patient, and go slow because nothing is more frustrating than doing a whole page of work and you missed it by a sign in the first step. Okay. All right. So, I'm going to show my work down here. Okay, so that's going to be -x, and that's going to be a +2y, and a -3z, and a -1. Okay, and I have x plus 2y minus z equals 13. Okay, and you don't have to bring down that third one because we're not really working with that. But if you want to bring it down, that's fine. I'm going to leave it up there. okay? Because I'm trying to combine these two to eliminate that x that's in the middle there. Okay, so I'm going to go ahead and combine these. And these cancel, which is what I wanted. And I get 4y minus 4z equals 12. This is what I'm talking about. I like to look to see if the equation has any common factors so that I can divide the equation by that and work with smaller numbers. Notice how here they're all divisible by 4. So let's make these numbers smaller by dividing them all by 4. If I do that, I get y minus z equals 3. Okay. All right. So let's take a look at what we did here. So I multiplied that first equation by -1. And I did that because I wanted to get rid of this x that's circled. Okay. And I got rid of that x that's circled because see here, they got canceled. And so what I do here is I'm going to replace that second equation with my result. Okay, so I'm going to replace that second equation over here with this. Okay, so this is what I'm going to have. I'll keep my original. My second equation, I eliminated that x, and I'm going to write down my result, which is y minus z equals 3. Okay. And now I have that 3x plus 2y minus 5z equals 3. Okay, so now I need to eliminate this one using that x, which means now I need to multiply that by -3 in order to cancel out that 3x. Okay, so I'm going to do all of my work down below. Okay, so here I'll do my work down below here. So -3x plus 6y minus 9z equals -3. And I'm going to double check my work because it's late. Let's see, -3x, positive 6y, -9z, -3. Okay. And I'm doing my work with just the first one and the third one. So I'm not going to bring that middle one, y minus z equals 3. I'm not really working with that one right now. So I'm going to just leave it there. And I'm going to bring down that third one. Okay, because I'm trying to eliminate that 3x that's circled. All right. Well, if I combine these, the 3x gets canceled. So, and I end up with 8y minus 14z equals 0. Nothing wrong with that 0. 0 is a valid number. Okay, so this one where the x is eliminated will replace that third one. Okay, so I'm going to bring down that first equation, x minus 2y plus 3z equals 1. Here, I'll do this. I'll do it here. So my new equations, my new system is x minus 2y plus 3z equals 1. Yeah, plus 3z equals 1. Okay, x minus 2y plus 3z equals 1. My second equation is y minus z equals 3. And my third equation is the latest one that I got, this one over here, 8y minus 14z equals 0. All right, so I'm on my way to getting that triangle. So remember that triangle at the very beginning? We said, oh, I need to get rid of these 3 terms right over here. Okay, so far I got rid of that one. I got rid of that one. And so now I need to get rid of this one. Okay, this 8y. I still need to get rid of this one. And we said we are going to use this. Okay, that's how it works for all of them. Okay. All right, so if I'm going to use that and I want to eliminate 8y, then it looks like I'm going to have to multiply this second one with -8 to eliminate that 8y, right? Okay. So let me multiply that one by 8, and I'll get -8y plus 8z equals -24. Okay, and I'll bring down that bottom one because that's the one I'm trying to eliminate. Okay, so I have this, and now I can combine them. And I see that they do eliminate. And here I get -6 equals -24. Divide both sides by -6, and I get 4. Okay, z equals 4. So that is what I'm going to replace this third equation with. Okay, so I'll keep the one with all three, x minus 2y plus 3z equals 1. I'll keep the second one with the y and the minus z. And I'll use this new one with just the z for the third one. And there you have your triangular form. When you have triangular form, you can use back substitution. Well, I have this answer already, z equals 4. So I'm going to plug that in here. So y minus 4 equals 3. So y equals 7. Here. Okay, and now I can take both of these, right? The y and the z, and plug them both in here, the first one, and solve for x. Okay, so x minus 2 times 7 plus 3 times 4 equals 1. So x minus 14 plus 12 equals 1. And combine like terms, x equals 3. Okay, so my answer here will be 374. Okay, all right, so let's kind of look back to the very beginning because there's a lot going on here. Okay, so like we said, you need to get rid of, here, let me see if I can erase some of this. You need to get rid of this x. Here, let me use my mouse. Okay, so you need to eliminate this x. You need to eliminate this 3x, and you need to eliminate this one. That's triangular form. Getting rid of this term, this one, and this one. It's like an L. Okay, you have to eliminate them. Okay, the way you eliminate these two is by using this top one. Okay, and using elimination method. Okay, if I want to cancel out x, this needs to be a -1x. So I multiply by -1. And so I do that work here. I bring this one down, and they eliminate. Okay, they eliminate. And I get this new equation. So then I replace the second equation with this new one, y minus c equals 3. So that's why I have this. Okay, it got eliminated. You're trying to eliminate the x. We did it. Okay, now we need to eliminate the 3x, right? So that's over here. If I want to eliminate 3x, again, I have to use this. Okay, so I need to make this a -3. Okay, So I multiply everything here by -3. I get this. I bring this down. They cancel. That's how you eliminate it. They get eliminated. This is what you get. So that will replace this whole new row. Okay? So I'm going to keep this one. I'm going to keep this one. And for my third row, my third equation, I'm going to use this one. And that's how I get this. Okay? I almost have my triangle. I still need to get rid of this one that's circled in green. If I want to get rid of this one, I have to use this directly above it. And if I want to eliminate this, this needs to be a -8y. So I need to multiply this by -8. So let's see. I do the work down here. Multiply this by -8. I get that. Bring this down. Sure enough, they eliminate. This is what I get. So that's going to replace my the third row. Okay. So I'm going to keep this one that has all 3, this one that has 2, and this one that has 1 variable. Okay. Keep this one that has all 3 variables, this one that has 2 variables, and this one that has 1. And that's how I have this, and that's triangular form. Once it's in triangular form, you can back substitute. Plug this in for z, solve for y. Plug in for z and y, solve for x. And we get 374. Okay. All right. So that is about it. So you just have to kind of keep track of everything as you're working through these. If some of you guys would like to see another example of this, then just message me and let me know that you want to see another example of Gaussian elimination. Okay, and I'll make another video with another example like this. Okay, all right. Other than that, if you have any questions, feel free to email me or message me.